Hey guys, welcome back to Consistent Code. So today's problem of the day is sequence 1. Basically what this problem says is that we are given a sequence and we need to find the nth term of this given sequence. So the sequence is as follows: 2, 5, 16, 65, and so on. So this is the sequence which we are having: 2, then 5, then 16 and 65, and this sequence continues, and this is for n equals to 1, 2, 3, 4, and so on. So the question says that you will be given, you need to find the nth term when you will be given an n. For example, if you are given n equals to 4, then your answer should be 65. Okay, so how to solve this problem? So to solve this problem, the first thing which we need to do is to determine the nth term, or we need to find an general expression for the nth term. Okay, so let's do that. So how to do that? So for that, you can just see that suppose I'm having n equals to 1. Okay, so what relation can you observe between the first term and the second term? So you should be able to see that if I double this 2 and add 1 to it, that is 2 into 2 plus 1 is 5. Okay, we are just trying to find a relation first. Then just check for this 5 and 16. So how can I convert this 5 into the 16? I can just write 5 into let's say 3 plus 1, that is a 16, or maybe 5 into 2 plus 6, right? That is also a 16. Now let's try to convert the 16 into 65. So that can be done by 16 into 4 plus 1, that is a 65, or 16 into 3, that is 48, plus something, that is 10, and 48 plus 10 will be 58, and we need 6 more. So that becomes approximately 60. So that is also 65. So as we can see from these expressions, what one thing which we can see is that if we consider these expressions, there is something which we can observe. And what is that thing? That thing is that in all of them, 1 is being added, and this is the previous number. Okay, and we are multiplying it by 2, then 3, and then 4. So this thing can be observed, right? So can we generalize this expression? So can I say the nth term Tn is equals to T of n minus 1, the term previous to this, and that term should be multiplied by the value. Suppose if it was 5, then it is being multiplied by 2. If it was 16, then 5 was being multiplied by 3, right? Hence I can say that Tn into n plus 1. Can I say this as the general expression for all of these terms? Yes, I can say that, right? So now that we have got the general expression, we can easily code this. But in code also we can just there are one approaches, you can just use a recursive approach. Okay, but as you can see in recursion approach, you have overlapping some problems, right? So to optimize this recursive solution, we can use dynamic programming, or you can also call in this case prefix suffix array type. Okay, and that is we are storing something. So you can also consider it as a DB. Okay, so how to do this? So first of all, what we will do, we will just check out the constraints. As you can see, that the constraints are till 10 to the power 4. So n will be in this range. So we can initially calculate the answer for all the n from 1 to 10 to the power 4, and whatever value is asked we can simply return this. So we can just create a hash table or a vector or an array for these number of n, and we can store all the values for these particular n, right? And we need to output our answer as modulo 10 to the power 9 plus m. So initially let's create this m as 29 plus 7, that is 10 to the power 9 plus 7 as a mod, right? And now I want that I should first store all of these answers. So let me just create a global variable that is a check equals to 0. Now why am I creating this variable? So I can just check, what will this check tell us? That if we have all the answers pre-calculated, okay, so we are just going to calculate all the answers once, and then we can simply return the answer for whatever n they ask. So now we will just check whenever our function is called, that if it is not checked, that is we have not pre-calculated, then we can say first we will pre-calculate, okay. And now what we will do in this pre-calculate function, so this will be a void function. What should this function do? It should first declare that we have pre-calculated all, that is check equals to 1, and now we need to just calculate this thing. So here I would like to have you can say a vector, a global vector of size 1000, 10 to the power 4 plus 1, right? So this will be the size. So I can initialize the 0th index as you can say 1, okay, and then we can just use this expression which we derived. So the t which is here can be replaced by my dp, right? So I can just say that dp of I is equals to dp of I minus 1 into my I plus 1. Can I say that this is a true expression? So yeah, this is a true expression. So let's just check this once. For example, if n is equals to 2, then I can just say dp of 2 will be equals to dp of 1 into 2 plus 1, right? So what will be dp of 1? I have initialized dp of 0 as 1, so dp of 1 will be this 1 into dp of 0, that is 1 plus 1, that is 2. So 2 into 2 plus 1, that is a 5, so that is a correct. So I can just write this equation here. So for int I equals to 1, I less than equals to 10 to the power 4, and I plus plus, I can just say that dp of I should be equals to dp of I minus 1 should be multiplied by I and incremented by 1. And also here we want to take modulo m, okay. And also let's say that this is long to be more safe, right? And also let's take a mod m here so that it does not overflow, and I think that should be good enough. Great. And so once we are done with pre-calculation, all that we need to do is simply returning the dp of n, right? So now let's try compiling and running our code and see if this is giving the correct output. So we are getting the correct output. So now let's submit the code and see if we are able to solve this problem. And we have solved this problem successfully. And I hope you like this explanation. And if you did so, make sure you hit the like button and subscribe to the channel. And I will keep uploading the next problem of the day. So I will see you tomorrow with the next problem of the day.